graded index multimode optical fibers. Okay, and I hope from the last lecture you are clear, everything is clear about this step index multimode optical fibers. But still, just to make it convenient for you people, okay, a continuity between this today's content and the last content. So let me go through the previous one or two slides so that a proper continuity will be there and you people may be able to understand properly. Okay. So here is the things. If you remember, then these are the types of multimode fibers we discussed: step index and graded index. We have seen the differences also between these two. Step index also we have seen with the profile, refractive index profile we have considered for this fiber, as well as we have seen the input signal and the output signal also. Okay, the differences between these two. And then here some few other details we have covered about the step index multimode fibers. Okay, their diameter, co-diameter, etc., and the path which are going to be followed inside the optical fiber. So all such things, and what is the outcome which we are getting from this optical fiber, that also discussed. So basically, your pulse is getting spread at the end. So that's how we discussed this last time. And this was the phenomena which was responsible for such kind of problems. Okay, so that is model dispersion. So it's very clear. I have highlighted, I have written over here. Let me annotate this once again. Okay, so you look at this part. So the arrival of different modes of the light, okay, at different times is called the modal dispersion. Okay, and that is why we are getting our pulse as a broad pulse rather than a intense pulse. We are getting a broad pulse you see at the output. Okay, but input you see is very intense. So that's how, because of this, we are having the problem in the step index optical fiber. But remember one thing, it is a continuous development, one can say. So earlier we have such concept where this step index fiber is there, but then we have identified there is a problem with this optical fiber and we are not getting our output as a perfect compared to the input. So then they thought of the problem, where exactly the problem is. So they come out with idea with this core refractive index. So right now in this step index optical fiber, the core, the central part, or let's say the core basically, okay, it has uniform refractive index, okay, throughout the core, and suddenly jumping towards the cladding. Okay, at the cladding part it is changing. So that is why we are saying that refractive index is changing in form of a step. But how to overcome this problem, because problem is here only. So they come up with the idea of graded index optical fiber. So that today we need to discuss that only. So I hope now the background is clear. Okay, the purpose, why step index, then why graded index. So it all you can consider it's a second version of this. Okay, to overcome the problem which we are facing in the step index optical fiber. So let me move. Okay, here you see the graded index multimode optical fibers diagram. I hope you are able to see. Now important thing is I have told to you theoretically that we need to change the refractive index, okay, in the core itself. And keeping in mind, since we need to follow the TIR pattern also, so we are knowing that light has to travel from dense medium towards rare medium, and that is why inside that core part, okay, in the core diameter, the central part of the core has to be maximum refractive index. Okay, and that is why, so how to change the refractive index inside the core itself? So they come up with the idea of multiple layers of the glass. Okay, so the central layer which is there in the core diameter part, okay, that has to be very high refractive index, and other another layers which are on the subsequent layers basically, so that has to be slightly less refractive index compared to the earlier one. And slowly you move towards the cladding side. Okay, so you can consider, you, as in the diagram it is clear, there are so many layers, your dotted lines you can see that. So these are representing basically layers. So different layers are there with slightly less refractive index compared to the earlier one, and slowly they are decreasing towards the cladding side. Okay, so here in the cladding side it is decreasing, and at this core cladding interface, the refractive index difference between core part and the cladding part is very minimum. Okay, so that's how we are saying so gradually decreasing towards cladding side, and that is why the name you see graded index optical fiber. Okay, so all such things you see, and if you see that there are multiple places, I have put this bar, this one, this one, this one. That means light is getting reflected from these points. Okay, there are multiple layers. Okay, and I you remember one more thing, that each time whenever it is moved towards rare to dense to rare medium, it has to follow the TIR. So these are the, you see, different layers bar. From there, this light is getting diverted, okay, following the TIR pattern and moving in this arrangement. Fine. Now, important thing is, because of this, what is happening over here? In the earlier one, the light was following the zigzag path, okay, but here you see it is not zigzag, but it is a like a helical path, basically, if you see carefully, almost helical like. So that is how one can, so multiple times your light is getting reflected from different layers, like in this manner, okay. So now coming to this next, which is there, this part. So this, because of this, okay, we can solve the problem of model dispersion. Now how can we solve it? We'll see in the next diagram how we can recover or come to this problem, overcome this problem. Okay, now you see graded index multimode optical fiber. Okay, so as I said, again gradually decreasing. Okay, from the center axis towards the cladding. Now here you see again, this is the same setup. Okay, and slightly I have used these kind of lines. Okay, you see the helical path. Now important thing is, see, you see the problem which was there in the earlier case in the step index optical fiber, that your signals are, or your lights are coming at different time interval. Okay, your pulse is arriving at different time interval, and that is why the pulse spreading was there. But why? Because that is was the zigzag pattern also going to be followed inside the optical fiber. But here you see in this graded index, it is almost smooth. Okay, and another thing is, you people are knowing that the light travel faster, okay, when the medium is rare. So that is why we are using this concept over here in the graded index. Okay, so at the center part, if you look at, as I said, the refractive index is maximum, so of course the speed of light will be small, will be less, okay, compared to the other layers, because there the medium or the refractive index is less compared to the central part. Okay, so you can imagine at the center the speed of light is less, but at the outer end of the core, okay, or near to cladding, you consider the speed will be maximum, because there the refractive index is less compared to the core refractive index, central part of the core refractive index. So that is why from the center side, suppose if some signal is traveling like this, okay, so here the speed will be less, but if it is following this path, so near to this central part it is less, but in the outer part like this, here it will cover larger distance because of high speed. So that is why you see almost at the same interval, I'm not saying it is exactly same, it is almost same interval. Let me annotate it, clear it out again and annotate. So you see this point also they are reaching at almost same, even at this point also it is reaching almost as same. Okay, same way here also, of course slightly differences are there, and that is why I told you this particular graded index fiber can minimize the losses, okay, which are happening in a step index optical fiber. It is not completely removing, keep in mind, okay, but it can minimize the losses. Dispersion loss can be minimized using this graded index optical fiber because of this concept. So you see their arrival time is almost same, I mean they are moving with the same, you see both are all the pulses which are following different path, but you see when they are going to come out, they will come out at almost same interval. Okay, so you forget about this extra part, suppose this wire length will be more, so you consider up to this only, like this. So you see this is the end, suppose, so you see all the signals or the paths, okay, they are coming out at the same time. This is the incident one, and they will almost coming out same. So that's why the chances of losses of dispersion is very less, and that is why even though if it is not broad, but somehow intense pulse you will get. Of course it may not be that much high intense as in the input, but slightly less intense peak you will get it over here. Okay, almost, so one can consider, because losses are very less, so one can consider almost similar pulse one can get at the output end. But remember, it is not equivalent to the input pulse, because you see this particular fiber can minimize the losses, it cannot remove it perfectly. So just keep in mind, okay, because wordings are very important. So same thing, same idea concept they have written over here, so you just go through it, I mean the same thing. So you see a digital pulse suffers less modal dispersion. So this is the main criteria which we have overcome in this optical fiber case. Okay, so the purpose is this only. And let me come down to the other part. Here is the comparison. Okay, so step index multimode मैंने compare किया. All three optical fiber cases I have compared over here. So you see step index, this is the source and these are the paths following inside this. Okay, light rays are coming out at different time, arrival time is different. Okay, and here you see in the graded index, okay, of course you see the core diameter, it is large only compared to the single mode, it is large. Okay, so that is why more number of mode can be possible, and that's why we are saying it's a multi-mode. So both are the case of multi-mode, this also as well as this also. And again, to remind you, some people are classifying based on the refractive index also. So that's why this is step index and this is graded index. So don't need to worry. It's basically multi-mode only. And then you see this source again, and you see this light path. So basically they are following this kind of path every time, like this.
Hello, sir.
This one, okay. कि आपका लाइट मूव करेगा इस टाइप से. ऑफ कोर्स मैंने थोड़ा सा डिफरेंट वे में बताया, बट एक लूप के फॉर्म में आपका जो है. जस्ट 1 minute.
Someone was saying something. Hello.
Yes, sir. Hello.
Yes, sir.
Yes, please.
Sir, here the problem remains the same, no, of losing the data.
Just hold on. Wait a minute. Yes. Many can you
Hello.
repeat? Yes. Now you can repeat. Yes, I can hear. Any?
Sir, the problem remains the same, no, of this losing the data, because if all the frequency waves are intersecting, then every time they will form something else and then they will move forward.
No, intersecting not, but actually it seems like intersecting, but main thing is they are coming out at same interval, same time interval. They need to come out from this optical fiber. Then only you will get the intensity. Okay. So there are several paths again.
Spreading problem is
Again, let me complete. Again, it seems from this 2D diagram that they are intersecting, but it is not the case. Yeah, please.
Sir,
वर्जन का केस तो
एक आवाज नॉइज बहुत आ रहा है. Can you please repeat it again?
sir,
Yes.
मुझे डाउट है कि सर आपने बोला कि ग्रेडेड इंडेक्स में हेलिकल पाथ फॉलो करेगा, लेकिन वो तो आप बोल रहे हो जिगजैग जैसा, वो साइन फॉर्म के जैसा होना चाहिए ना, तो हेलिकल कैसे हुआ? हेलिकल तो स्प्रिंग होता है.
तो स्प्रिंग वाली बात नहीं, वो तो मैंने आपको एग्जांपल देके बताया. स्मूथ कर्व बनेगा, स्मूथ कर्व, इट लुक्स लाइक हेलिकल पाथ. ओके, यहाँ पे जो पिक्चर में आपको दिख रहा है इन दिस इमेज, व्हाटएवर यू सी, इट इज द परफेक्ट केस. ओके, और ये इसके चांस होने की बहुत कम, इसलिए मैंने आपको पहले वाला डायग्राम बताया. ये तो बिल्कुल एक परफेक्ट जो मेरे पास होना चाहिए वो इस टाइप से मेरा आउटपुट दिखता है, बट इसमें भी ये आपको एग्जैक्ट इस फॉर्म में तो नहीं मिलेगा.
ओके सर.
ओके, और भी कुछ डाउट है? प्लीज कंटिन्यू. एक क्वेरी है किसी का, सो मैंने भेजा है. जस्ट 1 मिनट. स्टेप इंडेक्स में डिस्पर्शन का केस ग्रेडेड कम है ना. स्टेप इंडेक्स में डिस्पर्शन ज्यादा है ना, ग्रेडेड में कम है. क्योंकि डिस्पर्शन कब होगा? जब आपका जो सिग्नल है आपको वो देखना है वेर इट इज कमिंग आउट फ्रॉम द ऑप्टिकल फाइबर. ओके, सो यू सी अगेन हियर इन दिस पार्ट, लेट मी एनोटेट वन मोर टाइम. So you see over here, okay, pulses are coming out at different time, different arrival time is there, and because of that signal is getting spread. Okay, but here you see all the signals, the path, whatever the light signal is following the path, they will come out at the same time from this. Okay, so that is why here you will get the high intense peak compared to this side, because here individual pulse strength is same, almost to the original one, but collectively if you see, then this is going to be spread like this, but here it will be very clear like this. Is there any doubt or further? Still, if you doubt,
No, sir.
okay. So then let me continue with that. Okay. Okay. We'll discuss one more time. No need to worry. Maybe after completing this lecture. Okay. So don't worry about it.
Okay, so now okay, so come to this. Let me annotate again. So now we'll discuss about the advantages as we have discussed in the case of single mode optical fiber also. So you see the advantages of multi-mode optical fiber. First, it can easily support most of the distance, okay, required for the local premises, okay, or enterprise networks. So one can go for this. So that is preferable. As I said, in the local distances, always you have to go for the multi-mode. And in the multi-mode also, you have seen these two categories: step index, graded index. So whichever way you like, but generally people prefers to use graded index, okay, because now you have seen the idea. And it can support, you see, 10 gigabits per second transmission up to 550. Just let me make it clear. Yeah, so up to 550 meter, you see, you can easily transmit or your data basically with these cables. Okay, now important thing is over here, this sketch basically, because many a times, let's discuss with an real life example, that many a times you people are taking the internet connection at your home, okay, or your premises, and then that service person, or maybe you may be thinking of taking, let's say, 2 mbps speed or 5 mbps speed, some. What happens is when you try to run some what do you say, when you try to access the internet, okay, and then you realize that the speed whatever you were expecting, it is not up to that mark. Okay, why? Because they are, if you remember carefully, they are giving you the speed, etc. They are claiming in this gigabits per second, and many a times you people, or we people are expecting the answer in gigabytes. So there is a difference between this GB and this GB. Okay, this is gigabits and this is gigabyte. So you see 8 के factor से आपका output कम हो ही जाना है, because they were saying right, company person is saying right, no need to query or answer to them. But what we are thinking is, we are thinking in terms of this GB. Okay, and we are thinking why our speed is getting very less. Okay, because of this factor only. Clear? So since you are from the computer background, so you may be knowing that bits and bytes difference. So is it 1 byte equal to 8 bits, if I'm correct? So you see, this is how one can play with these numbers. So 10 gigabits per second and 10 gigabytes per second, both are having large difference. Anyway, now coming to this easy to install, as I said, this optical fiber cables are very easy, okay, because the core diameter is large, so connecting, installing part is comparatively easy compared to the single mode optical fiber. And you see, this is also, connections can also be easily performed, or connecting, installation flexibility will be there. Of course, this cost saving factor will also be there. Okay, and that is why we are preferring multi-mode optical fibers. But again, it depends on the requirement also. And you see, have larger cores, so that can guide many modes simultaneously. So that is the advantage we are getting. Okay. Now coming to the next. So these are the advantages. Disadvantages you are knowing already. Okay. Now coming to this part, okay, the third category, in which we can decide or define the optical fiber, okay, based on the materials. So which kind of material one can use for preparing the optical fibers. So here it is, this one, plastic core and cladding. Okay, core cladding is there. So plastic core and cladding, that means both the materials of the core and cladding has to be of plastic only. Second case, glass core. Okay, so before coming to these three, okay, let me discuss a very simple case. Okay, there are two things one need to prepare: core and cladding. Okay, and there are two materials we are going to use, either glass or plastic. Okay, either glass or plastic we are going to use. Now you see, what happens is, again there are two probabilities. This core part also you can made with glass. Okay, this also you can made with plastic. Okay, same way this cladding also you can made with glass. Okay, or made with plastic. So you see, दो choice दोनों में है core के पास भी. Even in cladding also we have two choices. So if you look at total possible combinations, then there are total 4 possible combinations. Okay, so look at, out of 4 only 3 are working. The 3 I have listed over here, the one is not working. Why? Because which was the one which is not working? That was this plastic core and glass cladding. That was not the acceptable, because in that case the plastic will be having less refractive index compared to the glass, so your light will not follow the TIR pattern. And that is why the fourth choice, that is plastic core and glass cladding, is not possible. But otherwise you see all such things are there. You can make the fibers with plastic core, plastic cladding, provided plastic core part has to be high refractive index compared to cladding, and this second glass core, okay, with plastic cladding, this is also possible because glass core we are preparing. So this kind of fibers we are knowing as a PCS. Okay, plastic clad silicon, these are the different namings people are giving to these fibers. And other is this glass core and glass cladding, which we are knowing as SCS. Okay, silica clad silica, because we know that glass is nothing but made of silica only. So silica clad silica is naming given to this glass core and glass cladding. So of course, if I just want to ask from you people, whichever is having the very good feature. Okay, so you people will select this glass core and glass cladding. Because why we are selecting glass? Because glass will not absorb the amount of signal or light. Okay, absorbance is very less in case of glass material, but in case of plastic material they will absorb your light signal. So basically they are attenuating the signal. When you say attenuate, that means your signal is getting lost, okay, because of medium itself. So that is why preferable is glass core and glass cladding. But again, as I said, it depends on so much factors. Okay, so again it depends on so much factors. So accordingly one can select कि भाई मुझे plastic core चाहिए और plastic clad चाहिए, whatever. So that is how these 3 possible cases are there based on the material. Fourth one is not there, as I said. Okay, so keep in mind, remember one thing: whatever the material you use, central part, that means the core part, has high refractive index compared to the cladding. Then only your light will move or propagate inside the optical fiber. Let's come to this. Yeah, perfect. So this is the second. So again, I have made some comparison between these 2 to 3. So you look it out. Okay, silica fibers, that means basically glass fibers I am talking about. Okay, so you see both core and cladding are of glass, as I said. Very pure SiO2. Okay, or fused quartz also people are saying, quartz or something SiO2. So it's very pure compared to any other, and that is why it will not absorb the amount of light. And you see again, the purpose, as I was discussing, it mainly used due to their low intrinsic absorption. यानी खुद से intrinsic में खुद से absorb करने वाला जो feature है, that is very less. Okay, second is plastic fibers. So plastic core and plastic cladding both are of plastic only, so that is why we are saying plastic fiber. And another, you see, higher attenuation, that means ज्यादा loss होगा because दोनों ही आपके पास plastic के हैं. But see, why we are preferring is because it is easy to install. Okay, break होने के chance भी इतने नहीं रहेंगे because it is a plastic. And you see again, better when withstand, yani it can sustain large amount of stress compared to the glass fibers. Okay, that's why I told it is very, I mean, it may be sustain a large amount of stress ताकि वो easily break ना हो. Okay, compared to the glass. And then you see another factor, less expensive, and it is used for the short distances. So that is how you can just compare it out: silica fibers, plastic fibers. And another one is this one, plastic plate. So if you want to go for in between feature, okay, either silica or plastic, then of course you can take the combination of this plastic plate. Okay, this may glass is core and plastic will be working as cladding material. Fine, we'll discuss all such queries at the end of this, whatever you may have during this also, so don't need to worry. Then come to this. So this is also very important. Okay, so fiber optical communication link. So let's discuss this also in proper depth, because this is something very important. And this is so though it is written as fiber optic or fiber optical communication link, but forget about fiber optics also. Whatever be the communication happening between you and me, or between any two devices or something, you required a system, you required a communication link. Okay, so suppose if you want to contact to me, or if I want to contact to you people, then either we are taking the help of email or some WhatsApp, Telegram, or directly we are calling to each other or something. So a setup will be there. Okay, it is not like कि मैंने just किया मेरा मन हुआ और किसी से बात कर ली. It is not like you, that it has to follow a setup. Basically a communication system will be there, then only you can talk to the other person via some medium. So that is why this time we are also doing the same thing, but taking the help of optical fiber cables. Okay, so why it is, how we can do this. Okay, so before coming to this fiber optic part, we need to discuss the general idea behind this communication part. And if you remember, maybe in the first or second lecture we discussed about that. Okay, कि एक सिस्टम में आपके पास क्या क्या होना चाहिए. So basically you need signal that you need to modulate onto the carrier wave, then carrier wave you need to transmit to the other side. Okay, and then again you need to demodulate, and you have to get your original signal. Okay, entire process is going to be carried by a medium. So that medium is important, so medium part is going to be played by fiber optic. Okay, so now come to this, let me explain this to you. So this is your transmitter. Okay, signal, of course you require signal, then transmitter has some component inside it, driver and source. Okay, then this transmitter you need to connect this part to this some connections. Okay, or connectivity basically you need to provide to this transmitter. So it's basically connector, you say simple. Okay, which connects this transmitter to this optical fiber. So you require a connector. Okay, and this optical fiber is medium, as I said. And again you required a connector. You see, this is nothing but the connector only. So if you carefully see at two sided, one side of optical fiber, again you need connector. On the second hand of the optical fiber, again you need a connector. Fine. So important is this medium has to be connected. Okay, with transmitter as well as this receiver with the help of connector. So you see, important part is this transmitter and this receiver, and these two parts are connected with the help of connectors, of course with such medium. Okay, so this medium is their optical fiber. And in receiver also there are some components: detector, amplifier, output circuit. Okay, it may be more also, but few important I have highlighted over here: detector, amplifier, output circuit. And then finally you are going to take out your signal.
सर
Okay, yes.
सर वो अपन जो सिग्नल दे रहे हैं उसको है ना एम्पलीफाई करना पड़ेगा ना कैरियर वेव के ऊपर, तो वो कौन ड्राइवर करता है क्या सर ट्रांसमीटर के अंदर?
यस, ट्रांसमीटर में ही करना पड़ेगा आपको. ओके,
ये
वो
सोर्स क्या है?
ट्रांसमीटर के, यस, ये ट्रांसमीटर के अंदर आपका मॉड्यूलेट करने का काम है, रिसीवर के अंदर उसको डीमॉड्यूलेट करने का काम है.
सर सोर्स क्या करेगा? ये सोर्स ट्रांसमीटर के अंदर जो सोर्स है,
हाँ मैं बताता हूँ. ये सोर्स आपका कैरियर वेव वाला ही हो गया. जो सिग्नल है आपका उसको
तो
कैरी
कैरियर
करवाना
वेव
पड़ेगा ना.
प्रोवाइड कर रहा है और ड्राइवर उस कैरियर वेव के ऊपर है ना अपना सिग्नल को।
यस, वो कंट्रोलिंग पार्ट यहाँ पे हो रहा है ट्रांसमीटर के अंदर.
सर रिसीवर में डिटेक्टर क्या करेगा?
किसमें? वो ये
रिसीवर में।
डीमॉड्यूलेट करने का काम है.
तो फिर
जो
एम्पलीफाई
सिग्नल है
वापस करने
उसको,
की क्या जरूरत है?
आपको सिग्नल को सी, अगर आपका स्ट्रेंथ कम होता है या कुछ भी, आपके सिग्नल को इंक्रीज करना है थोड़ा सा, तो एम्पलीफायर इज रिक्वायर्ड. कई बार क्या होता है कि इतने सारे प्रोसेस में हो सकता है कि आपका सिग्नल थोड़ा सा वीक हो जाए. ओके, और मेनी टाइम्स व्हाट हैपेंस कि वो जो सिग्नल का जो स्ट्रेंथ है, इट मे नॉट बी इनफ. ओके, एंड दैट इज व्हाई इट मे नॉट बी come out from the system. So many times you need to amplify your signal so that it can be properly detected from this output circuit.
ठीक।
Okay, we'll discuss. I will give you the examples, a perfect example to understand everything in very simple term. Okay, so this is the general flow: transmitter, connector, etc. You have seen. Okay, so you go through this driver, source, two parts are there, connectors are there, and these three components are there in the receiver side. Just wait a minute. Okay, so now come to the example. Okay, so here you see important, this is signal in, right? And again, let me say one thing to you people, that I generally believe in giving the real life example which you can relate with to your surroundings. Okay, and many times I may have told you also that physics is very simple provided if you are able to relate with your surroundings things. Okay, so coming to this signal in is nothing but, let me remove it out everything first. Okay, and annotate one more time. So this signal in is nothing but, you consider your physics syllabus. ओके, सो ये फिजिक्स सिलेबस है आपके पास सिग्नल इन में, और आपको फिजिक्स अच्छा नहीं लगता है, देन यू कैन टेक अनदर सब्जेक्ट आल्सो, which ever you like, but since I am teaching physics over here, so I will consider physics as a input signal. Okay, now you people may have got some idea who is playing the role of transmitter. Okay, of course me. So I am going to play the role of transmitter over here in this part, and you are playing the role of receiver. Okay, and coming to this, what is the signal out? It is the output which you are getting from this particular subject. Okay, maybe at the end of the semester when you give your exam, and after that you will get the output test marks. Yes, perfect. So signal in is clear, this is your physics syllabus. Transmitter is clear, which is your faculty member. Okay, in your case right now it is me, and this receiver is of course you only, because you are getting the content at the other end. I am transmitting the content. Okay, and the signal out is basically depends on so many factors. Okay, you will provide the output from this. Now coming to the more depth, you required a medium also. Okay, so here you see in this setup it is optical fiber, but to transmit it I'm using this, let's say, wavex. Okay, so transmitter is there, I'm transmitting this content to you people through the wavex. Okay, so that medium can be considered as wavex. Okay, or else if you look at to the offline thing, okay, compared to this online, in the offline this part is going to be done by classrooms. Okay, this part is going to be done by classroom, but here it is, let's say, wavex. Okay, so it depends, that is what I said, आपके एग्जांपल्स ऐसे होने चाहिए जो कहीं भी चेंजेस आप कर पाओ, रियल लाइफ में आप चेंजेस कर पाओ, and these are the connectors. Okay, one sided, even in two sided also. Okay, so you see this, so this is the connector. That means if I need to transmit the signal, if I need to transmit the content of physics to you people, then I need to connect to this classroom. I need to come to the classroom. Suppose if it is offline, then I need to come physically to this classroom. You also need to come to this classroom. Okay, so basically there is a connector. Okay, and connector is connected with this medium. So I need to come over here, you need to come over here. Okay, so that is connector which is connecting. That means this medium, this classroom is nothing but, we are, I mean, it is connecting to us only through some connectors. Okay, I am to come over there. So this, what is this connector then? Okay, so this connector, you say let's say number of lectures. Okay, this connectors is nothing but the number of lectures. तो आप सोचो, अगर आप, मैं यहाँ पे 30 लेक्चर्स डिलीवर करता हूँ, बट आप 20 ही अटेंड करते हो, सो देन अगेन आपका कनेक्टर अगर मिसमैच हुआ या कनेक्टर लूज हुआ, तो मैंने ट्रांसमीटर से कंटेंट तो पूरा ट्रांसमिट किया था, बट आपने यहाँ कनेक्टर ही मिस कर दिया, तो यहाँ पे आउटपुट आपको कम ही मिलने वाला है. ओके, सो दिस कनेक्टर यू कंसिडर एज ए नंबर ऑफ लेक्चर्स. ओके, तो अगर मुझे 30 लेक्चर्स डिलीवर करने हैं, आई नीड टू कम टू द क्लास. अगर आपको 30 लेक्चर्स सुनने हैं, यू ऑल्सो नीड टू कम टू द क्लास. सो दैट्स व्हाई दिस connectivity, this number of lectures are important. Okay, in which I need to cover the entire syllabus. Coming to the more depth part of this transmitter. Okay, so suppose, as I said, transmitter role is going to be played by your faculty member. Okay, so I know properly, I know very much, like up to how much depth I need to go through. Okay, or I need to transfer the content to you people. Fine. Another thing is, I also know what kind of examples I need to set so that I can transmit my content 100% to you people. Okay, another thing is that I also know at what particular pace I need to go to deliver my content. Okay, whether it's a fast pace or very slow pace or maybe medium pace, but that part I can control it. Okay, from this transmitter side, you see. So you imagine that all such part are going to be played by me. I can control your content, कितना कंटेंट मुझे देना है, कितने डेप्थ में देना है, राइट, क्या चीज आपको सजेस्ट करनी है, ओके, और कितनी तेजी से मुझे या कितना जल्दी से वो कंटेंट पढ़ाना है, कितना डेप्थ में पढ़ाना है, किस स्पीड से आपको पढ़ाना है, राइट, क्या एग्जांपल सेट करने हैं आपको समझाने के लिए. So that part is up to me. Okay, and I believe that faculty member is giving their 100%. I believe that कि no one is trying to keep some content कि नहीं मैं ज्यादा नहीं बताऊं, नहीं तो बच्चे मुझसे ज्यादा सीख जाएंगे. So it is not the case. So generally I believe transmitter is having all such criteria with them. Okay, वो depending on the requirement it can adjust it. Okay, because it also depends on the audience, the targeted audience or the receiver. कि अगर रिसीवर का लेवल उतना नहीं है तो उसको कंटेंट को उस हिसाब से मॉडिफाई करना पड़ेगा, थोड़ा चेंज करना पड़ेगा. सो दैट ऑल सच थिंग्स कैन बी डन बाय योर फैकल्टी मेंबर्स थ्रू दिस मीडियम. Okay, this I discussed. This connector is nothing but the number of lectures which I am going to deliver or you are going to receive at the other end. Optical fiber is the classroom, and as I said, this is very very important. So this is the place at which we both are coming. Okay, suppose if online it is webex, so webex is the medium at which we both are coming. I am also coming and you are also coming to listen that lecture. I am also coming to deliver the lecture. So this is very important. So you see, if any of the component, if you remove it, this transmission will not happen. Okay, even though all such things are there, suppose signal physics syllabus है, no doubt. Transmitter, that means faculties are also here. Okay, classes are also there. लेकिन अगर उसमें दूसरे एंड पे अगर बच्चे आ ही नहीं रहे हैं, then this entire process is useless. Okay, so let's consider कि up to this point, let me clear it out everything. So let's consider up to this point, okay, everything is working. Okay, everything is working almost, let's say not 100, then 99% it is working properly. Hardly 1 or 2% may vary, but otherwise it's working fine. Coming to this side, okay, on the other end you are connected with this connector. That means you need to attend all 30 or whatever with 30 or 45 number of lectures are there in a particular subject. You need to attend that. अगर आपका एक भी connector miss होता है, and now you people have gone through some earlier example also which I have given to you, that if any one of the connector is also losing or mismatching, okay, or not properly connected, then it may affect the performance of the all subject. So आपका जो ओवरऑल ग्रेड आएगा, अगर आपका एक कनेक्टर भी मिस हो जाता है किसी सब्जेक्ट का, एक लेक्चर भी मिस होता है, यानी आपका एक सब्जेक्ट का ग्रेड डाउन हुआ, तो ओवरऑल जो आपके सारे सब्जेक्ट्स के ग्रेड होंगे उसका भी वो डाउन कर देगा, CGPA या आप जो भी बोलो. So that is why this number of lectures are very very important. So don't try to miss any of the lecture. Okay, and that is why I said many times it's better to always join the class before time rather than after time. And coming to this important part, this of course I consider is a very very important part. Okay, receiver. Now why I consider this as important, because I consider up to this point there is no problem. Okay, but sometimes, I am not saying every time, but sometimes some problem may occur at the receiver end. Okay, sometimes some problem may occur at the receiver end. Receiver is nothing but you only. So now you see this receiver has three important components. Okay, first is the detector. I hope now you are getting the point. Detector is what? First you need to identify the content, you need to understand the content. Okay, लेकिन अगर आपने आपका माइंड ही वन करके बैठे हो या आपने आपका माइंड डाइवर्ट करके रखा है क्लास के टाइम से, then you are not going to detect the signal, which is very important. Okay, so whatever the content which we are transmitting through this channel up to this point, okay, it is coming up to this also. Suppose this, you are coming to this classroom also, you are attending the lectures also. Okay, so let's consider you are attending the lecture also, but somehow your mind is getting diverted. Okay, or you are in the class but your mind may not be in the classroom or content itself. So then this kind of receiver, okay, will create the problem at the output. Okay, क्योंकि आप सिग्नल को डिटेक्ट ही नहीं कर रहे हो. Forget about the demodulating part. You are not detecting the signal itself. सो कन्वर्ट करने के चांस तो काफी कम है, डिमोडुलेट करने के चांस काफी कम है. सो दैट इज व्हाई योर डिटेक्टर नीड्स टू बी ऑन कंटिन्यूअसली थ्रू आउट द लेक्चर. ओके, थोड़े टाइम भी अगर आपने डिटेक्टर बंद किया, या आपने थिंकिंग आपका बंद किया, या आपने अंडरस्टैंडिंग पे ध्यान नहीं दिया, या आपने इधर उधर ध्यान डाइवर्ट किया, वो डिटेक्टर से कंटेंट उतना चले जाएगा. सो दिस इज फर्स्ट स्टेप कि डिटेक्टर आपको ऑन रखना है, यानी सिग्नल को आने देना है. ठीक है, देन अगर आपने सब कुछ आने दिया, आप कन्वर्ट कर पा रहे हो उस पार्ट में, देन यू नीड टू एम्पलीफाई योर सिग्नल. दैट मीन्स सपोज आज आपने सिग्नल को रिसीव किया, आपने समझ भी लिया क्लास में कि मैंने जो पढ़ाया और आपने क्या समझा, वो सपोज 100% आपको समझ में आ गया. बट आफ्टर अ सर्टेन टाइम यू मे नीड टू रिवाइज, यू मे नीड टू एम्पलीफाई योर कंटेंट. अदरवाइज क्या होगा, कुछ टाइम बाद आप हो सकता है कि उसमें से कुछ भूल भी जाओ. सो आपको आपके सिग्नल को टाइम टाइम पे थोड़ा सा एम्पलीफाई करना पड़ेगा, यानी कि उस प्रोसेस को थोड़ा सा रिवाइज करना पड़ेगा, ताकि जो आपका आउटपुट है वो और अच्छा मिले. ठीक है, और अच्छा आपको बढ़ाना है आउटपुट, सो आपको और डेप्थ में जाना पड़े और अच्छे से पढ़ना पड़े. सो दैट इज व्हाई दिस एम्पलीफायर प्रोसेस इज देयर. Okay, now coming to this output circuit. So suppose if I again assume the detector is also working fine, amplifier is also working fine, that means on the time to time you are going to revise the content also. Then coming to this output. Okay, now this output circuit is nothing but your test. It may be class test also, it may be mid-sem exam also, it may be final exam also. Okay, so this output circuit is very important, because depending on the nature of exam, you need to change your output circuit. Okay, let me give you an example again. Suppose कोई particular topic है, क्लास टेस्ट में हो सकता है कि 1 या 2 मार्क्स का पूछा हो, बट मिड सेम में हो सकता है वो 3 मार्क्स में पूछा हो, एंड सेम थिंग कैन कम आउट with 5 marks in final exam. So you people need to write accordingly. It is not like कि आपने 5 मार्क्स में कुछ पूछा लेकिन आपने आंसर उसका 1 मार्क के हिसाब से ही दिया. Clear? So this output circuit is important, because depending on the nature of exam, you need to write the answer. कि कितने मार्क्स में आपको पूछा है, तो कितना आंसर इनफ होगा उस पर्टिकुलर न्यूमेरिकल्स के लिए या उस पर्टिकुलर प्रॉब्लम के लिए. सो दैट इज हाउ दिस आउटपुट सर्किट इज वेरी इंपॉर्टेंट. तो अगर आपने सपोज आपने यूनिफॉर्म ही रखा, सपोज अभी जो आपका रिसेंटली यू हैव गिवन द क्लास टेस्ट, and you just using the same circuit, let's say class test only, so in your mind it is fit like, okay, I need to select MCQs, I need to write only for the 30 marks, and if you're not going to change the circuit, then in final exam let's say of 100 marks, वो आप 30 marks के ही अटेम्प्ट करके आओगे. क्यों? क्योंकि आपने आउटपुट सर्किट को चेंज ही नहीं किया. so that is why it's very important you connect, okay, you select your output circuit as per the requirement. I hope you are getting the perfect idea. And again, if I consider, let me annotate, clear everything, and let me annotate. Yeah, so if I consider that all such process up to here it is working fine, almost 100% working fine, then you see your signal output, it is also maximum. But you remember, किसी भी साइड से अगर थोड़ा सा भी लूज हुआ, either this side, this side, this side, this side, you can imagine your signal, आउटपुट सिग्नल. सो अगर ये सब कुछ परफेक्टली होता है, देन जितना भी फिजिक्स का सिलेबस है जो मैं आपको ट्रांसमिट करूंगा, वो पूरा 100% आपके पास आउटपुट में आ जाना चाहिए. बट वी ऑल्सो नो दैट it's theoretically we are speaking 100%, but in practical we know our limits. Okay, so in some cases, for you people, in some cases this may vary, because we have seen from the last years, so this output signal may vary from 30 to 100%. Okay, so someone is getting 30% marks, someone is getting 40%, someone maybe 50%, 60%, 70, 80, 90, 100 भी मिलता है. So depends, आपके डिटेक्टर्स, कनेक्टर्स, एम्पलीफायर्स, आउटपुट सर्किट, वो आपके सारे प्रॉपरली यूज किए होना चाहिए सिस्टम के अंदर.